Hey guys, welcome back to the Basement Workshop. I recently acquired this vintage Hewlett-Packard spectrum analyzer, and I talked about it in a recent video. We did a basic checkout and tried to power it up, but I'm missing the interconnect cables. I ordered them and I thought they would have arrived by now, but it looks like they won't until early next week, so we can't do anything more with it for now. So I am going to post some footage I did a while ago on this classic Motorola electrostatic TV chassis, which will dovetail nicely with the series I did recently on a beginner's guide to electrostatic TV restoration. So enjoy. Alright, here it is up on the workbench. Now if you've been watching my channel for a while, you've probably seen me work on this before. I've worked on a bunch of these over the years, got a lot of videos on them, as do other YouTubers, so I'm just going to focus on the highlights. First off, what is this? This is a TS18, I do believe. Yep, stamped right there on the back. There's a lot of variations of these. They started out with the TS4 in late 47, made them through 48 into 49. When they switched to the TS18, which is a slight refinement. Probably mostly to lower cost, because they made a lot of these. And by a lot, I'm talking like 100,000 of the TS4, maybe 100,000 of the TS18s. How do I know that? Because I started tracking serial numbers for a while. On the backs of these, you'll usually find a serial number stamp, sometimes manufacture date. Now I notice this one's a little odd. Maybe it's a bad strike. It's 3191, then a space, then a 1. That's not typical. I think we're missing a digit here. Otherwise, I maintain a database of serial numbers to manufacturer dates. So given a serial number, I can tell you, I could tell somebody approximately when it was made. Anyway, even within the 18s, there are a couple versions. There's the TS18, the TS18A. Some are copper plated, some are not. This obviously is one of the copper plated ones. Steel underneath. If you want to try polishing it up, be my guest, but I'll tell you, it's typically not the greatest quality plating, and it might be missing in places. You try polishing it, you might go right through it. I'm just going to clean this up. And actually, I think this is, I thought maybe I was missing some plating here. No, it's just really dirty. Also a little bit musty. I think this was stored in a damp environment at some point, which hopefully won't come back to bite us with damp coils. Now, I've had this for a few years. It's been in a dry area, so I shouldn't say wet coils are damp. I mean, they're not damp anymore. The question is in the past, when they got damp, did it corrode any windings inside? I'm talking about a transformer like this, or which is horizontal sweep transformer, audio output transformer. Anyways, getting ahead of myself. Right? So let's assume you've got a good picture tube. What are we going to work on first? Power supply. Always power supply. Now, these are a little bit goofy because, well, you're trying to keep costs down, so there's no power transformer. Not exactly a hot chassis set. This metal chassis is not connected to the AC line. Wiring underneath is, but this is floating. It's isolated. But these caps, these two in particular, the negative side on these does go to the AC line. That's why they have cardboard covers. That's why they're on insulated phenolic wafers, because you do not want to have this metal touch this. Notice this one does not have a cardboard cover. Oh, my memory is failing me a little bit. It might have had one and it got lost, or maybe the can on this is not attached to one side of the AC line, so it's but I think all three of these are, so be aware of that when you're replacing them. And the other big weirdness, well, is this guy right here. That is the ballast tube, and that is the thing that I rebuilt one, and we want to try that out. These have 4 sections of nichrome resistance wire inside, exposed to air. They're not in a vacuum, and there's mica on there, and they're sort of held on little dabs of refractory cement. You can see this one's corroded. Usually inside they're miserable looking. The copper connections corrode, the wires fail, the little cement holding them in place fails. So I rebuild them, and you should too. And here's one I rebuilt. This is the one I want to test. Got a thermistor at the top for a slow start. And we've got power resistors to replace those resistive elements. And we also have a couple silicon diodes to form a more efficient type of filament dropper. I have a whole series of videos just on how I came up with the design for this. I encourage you to watch those. Just bungee beware, that's what I'm going to go with. Eventually I will rebuild this one as well. Now, something odd about this, it has had some work done. In particular, I believe the 2 selenium rectifiers were replaced. And I think while somebody was at it, they punched these holes. I don't think they're original. Well, it kind of looks like there's some copper plating around the side, but maybe that's just some surface corrosion. It's a little hard to tell. But I've never seen one that has these holes. And I've seen a few dozen of these, so I don't think it's original. That's my best guess as to what's going on there. Tubes are generally pretty common. We got 6AU6s, 6AG5, 6AL5, 25L6 audio output, 25L6 to drive the coil that's in here that makes the high voltage. 3 12SN7s. Those are generally the biggest pain. That's why I'm missing a couple here, because they're kind of hard to find and expensive when you do. So I scavenged the 2 from this to put into another set a while ago, so now I got to go hunting for some more. Also a 6SL7, which can get a little pricey, probably because of the audio crowd. I think that's what this is. So dirty I can't tell, but I'm pretty sure. 6SL7, yeah. And here's one 12SN7. It's probably seen a lot of hours because it's got those silver dots on top. It's a dual triode. That's why the audio folks like those. 6SN7s, also the prices inflate on those, but they're far more common. They use 12SN7s because it's a series strong set, and they wanted to get the filament voltages to add up as best they could to match the line voltage. Alright, so I'll have to dig up some tubes, and I haven't tested these yet, so we'll need a good set of tubes. And I'm going to go after replacing these 3 guys. I will use Adaptacaps. They're little insulated circuit boards that are made to replace these guys. So I'll be removing these. The mounting holes will line up with them. I'll pull some out and show you what they look like. That is an Adaptacap and a little business card holder. You can get them at adaptacap.com. I have a review video where I talk more about these. And you take them out of that frame. This is what they look like. So they will line up with these perfectly. You mount your new caps in the holes. These are also insulated. These are not connected to any of these unless you put a jumper in here. So we can mount our new caps on this, attach that, hook our wires up. Good to go. No, I'm not going to restuff these. Too time consuming for me to put onto a set that's relatively common. Alright, let's look underneath. Hey, by all means, if you want to unmount those caps and restuff them, knock yourself out. I just choose not to. So these are what I think are replacements. Because they're bigger than ones I've seen in the past, and they put some insulated boards in here. They're kind of crammed in here, so yeah, they're gonna go regardless whether they're new or not, because these do not age well. The internal resistance gets higher and higher, which makes them get hotter and hotter, and when they let loose, they release horrible smelling fumes from the selenium compounds vaporizing. You don't want to deal with that, so replace those with some silicon diodes, which will also free up room around here so we can get at the wiring, because those 3 electrolytics are right underneath them. There is the tuner. When I talked about cost savings measures with the TS18, that's one of them. This is as minimalistic a tuner as you can possibly get. Those coils are what set the local oscillator and the bandpass filters for each of the channels. Do not touch those. Do not move them. Don't even look at them too closely, because you will detune the tuner if you do anything over here. So, I'm not going to touch this area. The rest of it's pretty simple. There aren't that many caps to replace. We want to replace all these waxy caps. They're just going to be bad. Don't waste your time. They gotta go. Resistors, I typically replace the power resistor because it's part of the power supply and it's critical to the operation. They drift over time, so I'll replace those two guys. That is an electrolytic, an axial 10 microfarad, 50 volts for the audio. I'll replace that as well. And then we get to some other specialty parts, which have already been replaced, which are these. 1, 2, 3, 4, 5. Those are 6,000 volt caps. Those are used to couple signals from the rest of the set to the picture tube, which runs on around 5,000 volts or so. They're always bad. The original wax one's always bad. There's a chance these might still be good, but these are probably also paper inside. One's kind of oozing. They might be oil filled. Oh, and they actually use a 10,000 volt cap on that guy. That's the main filter cap right out of the high voltage supply, which is directly on the other side of this. We can give them a shot. They might still be okay. Also, I can see this black goo over here. There's probably some arcing issues, and somebody dabbed on some liquid electrical tape. Is the factory, is it, well, since they replaced these caps and it's on top of this, it must have been done when they replaced these caps. The 3 electrolytic cans have been replaced. Adding extension eyelets to the adapter caps made rewiring them a little bit easier. Added a terminal strip just for a single tie point for one of the new silicon diodes that replace the seleniums. Now I want to turn my attention to thinking about trying a first power up. Before I can do that, I want to check the tubes and replace some that are missing. In particular, these Motorola electrostatic sets, be they 7 or 8 inch, all use 3 12SN7 dual triode tubes, which are a little tough to come by. I mean, there are plenty of them out there. You jump on eBay or into tube vendors, they all have them. Depends how much you want to spend, because whenever you talk tryout, any tube has got a tryout in it, means somebody's going to make an amp out of it, which has driven the prices up. Plus, they're nowhere near as common as a 6SN7, which is a workhorse through the 40s and 50s. Just about every tube-based TV in that time frame used them. But the 12SN7s are particular to some electrostatic TVs. I took a quick look through my stash and came up with one. And I haven't checked the one that's left in this chassis. It might be bad. This one might be bad. So I want to find some others. But rather than spending more time digging through my stash, I looked around the workshop and realized I have 2 other Motorola sets up on a shelf back here that I don't believe I've ever looked inside of. I got them all. There was a collector who was downsizing. I got a bunch of stuff from him, including these 2 TVs and a spare chassis, which I think I know where that is, and that might have some as well, because it's an electrostatic set. Not a Motorola, but I think it might have 4 or 5 12SN7s, and I probably scavenged them then. But so we can kill a few birds with one stone. I'll have to move some stuff, but in particular, I want to check out that Bakelite. It's one of my all-time absolute favorite TVs, Motorola 7 VT2. Let me move some stuff, pull that out, get out a tube tester, and go through this. Now, when it comes to testing, it's series strung, right? So we have to populate every tube socket, including the picture tube, unless we do a little trick here. Instead of looking at the picture tube, we can put a power resistor between pins 1 and 14 to simulate the picture tube being there, at least to do a smoke test to see will it turn on and all that, before we risk damaging the very, very, very difficult to replace picture tube. So that's what I intend to do. I think I know I've rigged one up before that has scavenged some pins out of a tube and attached a power resistor, so plug in. I think it's 8 or 10 ohms, something like that. And obviously we still have paper caps to replace, but with the whole power supply rebuilt, should be able to turn it on and let me test my rebuilt ballast as well. There we go. I already took a peek in the back, and it's not what I remembered. It's been a while since I got this. Probably if I went back and watched the video I made when I got this, I already talked about it, but get older, your memory starts to turn to mush. So this has already been restored. I believe, I mean, at least I know work's been done to it. They added a thermistor up top, and when I took a look at the filament dropper, I can see there's power resistors inside, I think. Yeah. But it's odd because it still has some of the original mica elements, so I don't know if they just replaced a bad section or what all has been done. So I would definitely want to go over before I just powered it up. Strange stuff has been done to this. So they added knobs that are definitely not originally came from radios. So I don't know what's going on. Also has a chunk missing on the bottom. If you're going to have a damaged Bakelite case, of course, the back at the bottom is the best place to have it happen. Also a crack here. Cracks on both sides where the chassis screws go into this, and maybe they tightened them too much. Also hold the feet on. Or this got jostled around, or you know, in shipping, and it put stress on them. I don't know. Looks like they cleaned it up pretty well too. Like everything seems to be cleaned and polished. The high voltage buckle cover, the tube shield. Anyways, I plucked a bunch of tubes out of it, so we can give these a whirl. So we've got a bunch of 12SN7s to play around with now. I'm using a Sencor Mighty Mite 7 TC162 tube tester. It's a basic emission type tester, very versatile, and it's small, compact, but it can handle all the newer tube types from New Visters, Loctals, and of course the 7.5 pin miniatures and octals. I have good news. All the 12SN7s, all 5 of them I dug out, test fine. Now I'm doing the 6 AU6s. I believe there are 4, maybe 5 of them in this set. 2 of them are still the originals, and this is one of those. What I want to show you is, it doesn't have shorts. The emissions are fine. But when I check for grid leakage, bad. That's the bottom scale. When good would be 0 ideally, or just slightly above it. It's way into the bad. Most tube testers would not detect that. It doesn't show up as a short. It's most often I've seen it in IF tubes. I don't know if they're driven harder or it's just the nature of this type of tube, but what happens is material from the cathode finds its way onto the grid, and the grid leakage, sometimes also called secondary emission, the grid is actually emitting electrons, which means that the function of the tube is compromised. Now, would it work in the set? Yeah, probably. And you might not notice the difference until you tried putting in a tube that had great emissions and no grid leakage. It should work a little bit better. Would the end results be noticeable? I'm not sure. I'll put this aside, so we'll play around with that later. So only 3 of the tubes were originals. Here's another 6AU6 that's original. Let's see how that tests. And 6AG5, the RF amp right at the front end. Well, this is yellow and the other 2 are white, so this could be original or it could be a factory replacement. Numbers on it 2809-52. I'm not sure what that means. Could be 1952. I don't know. The other one has 3145, 31st week in 1945. I could believe that. And then a number that just means nothing. 322939. Internal code, I imagine. So, yeah, I'm not sure. But notice one's white, one yellow. I think this might mean it's a. It's old, but it's a replacement from way back then. So, alright, let's see how this other original 6AU6 fares. Great emissions. Much better grid leakage. Not quite 0, it's a little bit above, but still well into the green zone. So, we will keep this tube. So at least we'll have 1 original tube left in this set. Now let's see how the original 6 AG5 tests. So we gotta flip this to 6 and change this to E and pop it in. We're very streamlined. You generally only have to change the C control and rotate the D for shorts testing. You don't have all those knobs and switches like most testers do. Check for shorts. No shorts. And emissions. Well into the good. Grid leakage. Also good. Alright, we'll have 2 original tubes left in this set. Couple more to test. 12AT7 local oscillator mixer tube. Well, I guess I got lucky that 686 is the only tube I had any issues with whatsoever in terms of performance, but we do have 2 loose tubes. I did a recent tech tip video where I used some sodium silicate, aka liquid glass, to repair tube bases, and worked quite well. But one thing I noticed on this, the Type 83, which run a bit hot, is that it did get a little crusty around the edge, and it kind of flaked off, or is flaking off where it bonds to the glass, but it's on there very solidly. This was crazy loose before I put it on, so I've run this a couple hours in a tube tester just to give it some sort of endurance testing, and it seems to be okay. But I got a tip from a viewer that it may be possible to reactivate the old glue type stuff that they use to bond these, and I looked up the formula for it, and one of the ingredients is shellac. So I suspect what is potentially happening is the shellac is if you use denatured alcohol or acetone, it dissolves shellac even after it's set up. So I think that's what's reactivating it. So let's give that a shot on these. In particular, this one, because it's just barely loose. This one's quite loose. And, I don't know how much of the old adhesive material is left. But I think this one, if this is going to work at all, this one's more promising. And the stuff will just evaporate. If it doesn't work, we can try something else. I'm curious to try it. So it's certainly the easiest thing to do. And retains, you know, as much of the original as possible. So I've worked a bunch in there. It's not really biting, but it may take a while. A little more around. Also the 12SN7, I don't want super hot. The other one's a 25L6 and they want it really hot. That's one thing with the sodium silicate is excels at it, is very temperature resistant. So I'm not seeing much activity in this, but I'll let that sit while we proceed to do other stuff. And you know what the heck, I'll try it over here too. What we got to lose? Well, we'll populate the rest of the tube sockets, dig up another 686. And I mentioned about substituting a resistor for the CRT. Here we go. Here's my little test guide. It's a 10 ohm, 10 watt resistor. And we'll have the same filament resistance of the real tube, so I'll pop that in the tube socket. Now, since I still have a lot of work to do, I thought I'd play it safe, and I disconnected B+ down below. I disconnected the wire going to, I disconnected the first cap down in there, so there's only power going to the tube filaments. So, without further ado, here we go. Well, there is a CL90 inside here, so it makes sense that it'll take a little while for the current to stabilize. And there we go. All the tubes appear to be glowing correctly. If I screwed something up, either there'd be no tube glow or some would be super bright. Alright, I've reconnected the voltage doubler power supply that provides the plate voltage for all the circuits. I have my voltmeter connected to the output of that voltage doubler circuit. It should be around 240 volts or so on the meter. Got it plugged into my Variac. Let's give this a try. I don't have the set turned off. Oh, well, if I plugged it in. Alright, there we go. Let's try that again. Nope. Something not right. Oh, and it's drawing a lot of current. So, for those of you who have a dim bulb type setup, your bulb would have lit up bright. I don't. I used to a long time ago, but in lieu of that, I now use this guy, and you couldn't see it, but I could because I was watching it. Alright, so what I was looking at was the meter on this. I have it on the 1.5 amp scale. I know this set draws about an amp, just slightly over an amp or so when it's running properly. So when I turn this on, it pegged the meter. I'll show you that again. So that's not good. If I put it on a 4 amp scale, so it'd be 4 amps full scale, it's not getting there. We're under 2 amps total, so it's just off the scale on the 1.5 amp scale. So we're kind of dead short. In fact, I still am reading over 100 volts on my meter with the set turned off as the caps are slowly discharging. So, this is where your troubleshooting skills come into play. When it's a dead short, it's obvious. The circuit breaker on my supply would have immediately tripped. The meter would have pegged over, and we would have had 0 volts here or close to it. But we had like 2/3 of what we should have. So when we have a dead short, what we have is excessive current draw. Now, what's the most likely source of that? Well, 2 possibilities immediately jump to mind. 1, I made a mistake. Easy to do. I rebuilt this whole section. That's why people often tell you, don't shotgun the whole thing. Just do a section at a time. So I didn't do any of this stuff. I just rebuilt the power supply. But that can be a little bit of an issue because this power supply might be rebuilt and it's completely fine. It didn't make any mistakes. But because I have all these old leaky paper caps in there, they're drawing too much current. Again, when I have a dead short, and by that I don't necessarily mean that a cap has a lot of current going through it. But if it's attached to a circuit that provides bias to one of the tubes, especially one of the beam power tubes, one of the 25L6s, a leaky cap can alter the grid voltage and drive it so the tube is like full on, and the tube is drawing a ton of current. However, I don't think that's the case because it is immediately drawing too much current. The tubes haven't warmed up yet. So, that leads me back to thinking I might have made a mistake. So I will review my work. Now, I've done a bunch of these. I was pretty careful. I kept all the wiring intact as best I could. I've got my very accurate reference schematic. Nice, big, clear, easy to read. And it's not a dead short. Could have put a diode in backwards. Could have miswired something. Right, so here's the schematic. Now, if you haven't worked on these sets, if you haven't seen the schematic before, a couple things are kind of confusing. Let's go over it. Here's where our AC power comes in. One side of it goes right to this line down here, and here's our power switch, and then it goes off. That's essentially ground, you can think of it, or B minus, it's the return. It's not actually going to the chassis. It is through a 470K resistor, but it's not going directly to the chassis. But that's our ground. That's where I hooked up my meter, to this rail. The other side, part of it goes down, off, into all the tube filaments. We know that part of it's fine. All the tubes are lit up fine, the current draw is normal. It's the other side. It goes right to a 37 ohm resistor. Now, I'm just realizing something. When I said there's no dead short, actually there could be. I forgot a couple things. We have a current limiting resistor, 37 ohm right here. We also have another one here, 200 ohm, with a cap on either side. Now, only part of it, and then that goes to B++, but part of it does go off this way. And what does that go to? It actually goes to the video amp tube. Let's see if I can get my camera over to the other side of the schematic. So it is this line, yeah. So there's two big power resistors up in that corner of the chassis I mentioned earlier, or I'll point them out to you again. So 4.7K and a 6.8K. Those are going to that highest potential output of the voltage doubler, and that feeds the video amp tube. So we could have a problem there. The rest of the power to the set, this B++, all goes to this 200 ohm resistor, which is also inside of the ballast. So if we're dead shorted here, this resistor should get pretty toasty, as should that guy. Or if this resistor's cool, it could be the topmost is shorted. So how can we test that out? If I pull the ballast out, nothing's going to happen because neither the tubes or the supply will get any power. So I have to leave that in. So what I have to do is track down pin 3 on the ballast, for example. One, check resistance from that, not to the chassis. Well, I can do that too, but more importantly to this line, and see if there's a short. It could be. I didn't make any mistakes, but while I was working, I was snipping wires and soldering. Maybe a blob of solder or a clipped off lead fell into the chassis and shorted something. It absolutely can happen. Or this topmost can be shorted, and to test that, I would disconnect pin 4. So pin 3 and pin 4 are, you can think of that as the output of the supply. So pin 6 is power coming in to that ballast tube. And oh yeah, pin 3 and 4, so these are pins on the ballast tube. So pin 6 is power going into the ballast, and pins 3 or 4 are power coming out of the ballast. So if I isolate 3 and 4, there'll be no power going to the set. If I do that and turn it on, and the meter's getting pegged over, I made a mistake in here somewhere. If I disconnect those two and turn the set on and just the filaments light up and the current draw is fine, then there's something in the rest of the set that's a problem. Oh, now this is fun. I've been comparing the SAMs to the Wallace Telade. Noticed a couple things. Also noticed something on the chassis I'll show you in a moment. Let's take a real close look at this. So I already talked about the diodes. Look at the numbering here. On the left hand side we have pin 4. On the right hand side we have pin 3. On the SAMs on the left hand side we have pin 3. On the right hand side we have pin 4. So who is right? This is right when I compare it to the chassis wiring. Made me feel better. Reviewed the chassis more. Couldn't find for the life of me any problem underneath the chassis. I was reviewing the adapter caps and the wiring and was going to start unhooking things, and I took a look at the top of the chassis. You know, I was looking at the top of the chassis. I wanted to double check my tube placement. That can get kind of confusing because on the Wallace they show the bottom view of the tube chart, and I had at one point interchanged the these two tubes. So earlier I showed this tube being loose. It was actually supposed to go over in this socket. And whoa! What do you know? This is the tube I put alcohol into. That was 24 hours ago. And, you know, that is in there rock solid. Now this is a really loose one. That is in there solidly too. How about that? I guess it just took quite a while now. It's been 24 hours since I put it in. I couldn't tell you at what point it's set up, but I had completely given up on that. Huh. I don't know how long they'll hold, but that's not coming loose. Let me really yank on this one too. Huh. Alrighty then. So, that is worth trying, especially if it's a more delicate, fragile, older tube. You just got to be patient. Alright, back to the problem. So I was reviewing my capacitors. This one is bulging on top. That's the one right where the AC comes into the voltage doubler. Let's go back to the schematic, because there's a second problem where the two do not agree. And that is the orientation of that cap. So on the SAMs, they show minus going right to the AC line and then plus going to the doubler. This guy, which is what I was going off of when I wired it up, shows the opposite, but it's a little harder to figure because they don't show a plus and minus. They show a vertical line and a curved line. And if you could look over at these caps, the top sides are all like this and the bottoms are like that. In other words, the positive side is going up to these and the curve are all going to this negative bust down here. So following that same logic, they're showing it with the vertical bar, the positive side going to the AC line, which is the opposite of what SAMS shows. I think SAMS has this right and these pin numbers wrong, and the Wallace has this cap wrong, but this is right. Now, it's a classic circuit. It's been used many, many, many times, and I should know by memory which way that cap is supposed to go, but I don't. But this Wallace is chock full of other schematics, so let's find the TS4, which is the earlier version of this. Let's see which way it goes on that chassis. And here it is. And they show minus on the left, positive on the right. The same as the SAMs. And they show 4 on the left and 3 on the right, which is the opposite of what the SAM shows. Alright, so we have two schematics that show negative on the left, positive on the right. I have the opposite. My cap is bulging. I'm pretty sure that's the problem. Let's flip that cap. Well, I'm going to toss that cap, put a new one in. Luckily, I've got a few of that value, and let's give this another try. I think this is the first I've ever had to replace a cap in one of these adapter caps. At first I was going to undo the bottom, and I installed those extension lugs, and I wrapped the leads of the cap around them, and that's going to be kind of a pain in the butt. And I'm thinking, this is only a single cap version. I got a bunch of extra holes here. I should be able to just clip this out of the top and put a new one in. Now, the downside to this is when I put in the new one the other way, it's not going to agree with this plus and minus up top. So I think I am going to obliterate those to avoid confusing anyone in the future. Let's see, take a pocket knife here. Because I do not want to detach this or redo the wiring underneath. That would be crazy. Not gonna work. There we go. Let's just get rid of those entirely. Nobody will know. No, we need to put the positive to our upper left here. Remember that. Alrighty. So that. And this new guy, I can put it in anywhere. I can put it in right there. How about that? Now, for those of you who don't care for this modern look of these adapter caps with the shiny new caps sticking out, it's easy enough to remove the cardboard covers from the original caps and hide them underneath. Now, securing them, I've done a few ways. We've got unused pads here. You can take a bit of wire and stick it into the unused pads and bend them out so that they grip the cardboard tube when you slide it down, or take some bubble wrap or similar material to expand the diameter a bit and push this down, and it will hold it snug. And if you need to, you can remove them to check the caps. If you install them backwards like I did, you'll be able to get to it and repair it easily enough. So that takes care of that. Alright, here we go. Round 2. Voltmeter reattached. New cap installed. Yeah, we are good to go. Alright, 3, 2, 1. Contact. That's more like it. And the current draw, third of an amp, quarter of an amp, something like that. Should start going up around now as the tubes warm up, and the B++ should go down as the tubes are drawing more power. There we go. Excellent. See how I was wavering like that? Something's got to be breaking into oscillation because of all these bad old caps. Alright, there's one more thing we're going to do before I commence to do any more work, and that is grab this 6 kilovolt probe back here. I love using these electrostatic sets. It's a great thing about this old Fluke 27 FM. It's from the early 90s, I do believe. If you get the full accessory kit off the surplus market, they come with this probe, which is good up to 6,000 volts, which is perfect for electrostatic sets because they all run around 4 to 5,500 volts. You don't need a giant 20 or 30,000 volt high voltage probe. You can use this little guy, which I don't know why they included these originally. These are made for the military or government contract, I do believe. Alright, so we're going to see, do we have any high voltage? And the highest potential voltage will be this guy down here, this black cap on the left hand side. Right down in here is the base of the high voltage rectifier tube. So if we do have some high voltage, and the next thing I'm going to do is plug in a CRT. See if we get some glowage, because once we get something on a screen, then we can use that as a troubleshooting aid as we progress. Wait for the tubes to warm up again. There's a bunch of goo was put all over this, so it's going to interfere with me trying to take a measurement. But let's see. Alright, we got a couple hundred volts. It's pulsing too. So that's a little disappointing. Oh well. So is the cap leaky? Let's take a look. So I'm going right off that cap. It's the main high voltage filter cap. Got my vintage cap bridge out here. Light flashes. It's a bad cap. It's leaky with 200 volts on it. Violently leaky. Those caps are crap. Even at 100 volts, it's leaky. Alright, so we're done. All those caps got to go. There's no point in fooling around. I'm not going to replace them one at a time and power it up. If one's bad, they're all the same vintage. They're all going to be bad. I kind of figured that was the case. So I'll resume when they're all gone. I rebuilt the entire circuit down here, both replacing that high voltage cap and replacing a cap and 3 resistors on the oscillator driver for the high voltage coil. Now, the cap that was in there is actually a .0005. It's only 500 picofarad. Should be a 5,000 picofarad cap. And it's rated for 10,000 volts, and this was leaky at 100, so that is extremely bad cap. Alright, let's give this another try. I haven't replaced the other 4 yet, but this is the main supply. These are coupling caps. Even if they're leaky, we should still, if the circuit's working at all, get some high voltage down here now. Things are kicking in. Up to 3,000 volts. Try a little bit of an arc with my probe. Alright. Let's hook up a CRT. Went ahead and tacked in replacements for the other 4 high voltage caps. And I noticed some dubious old repairs in this area, which is a vertical oscillator. So I replaced those caps as well. Let's give it another go. Also tested the brightness control, and it is okay. And I sprayed some Deoxit F5 cleaner into all the controls, and I was able to free up the focus control with the help of some pliers and work the shaft back and forth a little bit, and here we go. Power is on. This is not the pitch tube that came with the set. This is a green phosphor oscilloscope CRT I use on the bench. So if it works, it'll be green, not white. Let's check our voltage 2 minutes. Oh, up to 6 kilovolts now. That's actually a little bit more than it should be. I mean, well, 6 kilovolt max is the rating on these. If you want to get the brightest possible picture, you want to get close to 6 kilovolts, so it's not going to harm anything. Just surprised because I usually get a little bit less than that in these sets. But obviously we don't see anything, so let's try that brightness control. Oh, there we go. So that's real bright. Turn that down. It's filling the screen pretty well. It is fantastic. We've got a raster, so that's what I meant by it. Once we get something on here, this will guide us in our continuing restoration. The set, I wouldn't quite call it a porthole set, but it should have a bit more height than that, I think. Let's see. This is the height control. So that's maxed out, so we're lacking some height. Of course, we won't know to put a signal in what kind of image we can get. I don't like this bright bar here too. I'll probably have some fold over or distortion in the sleep circuit, but that's fantastic. That's fantastic. It's very late. I'm going to bed. Really wanted to get something on the CRT before I called it a night, so we will continue tomorrow.